Hello, students. Hello. How many you all are there? Sure. Hello, everyone. Now, in the chapter Magnetism and Matter, anybody has any doubt? I'll just put up the formula and what do you say? Complete the chapter. So, do you have any doubt in the chapter Magnetism and Matter? I'll just put it up. Hello. Hello, is anybody there? Do you have any doubt, bro? Harsh, in Magnetism and Matter? Hi, everyone. So we'll be doing the chapter Magnetism and Matter. Students will be doing the chapter Magnetism and Matter, electromagnetic induction, and EM waves. These three will be targeting. Okay, these three will be one shot, like together, all the three covering all the concepts. Okay, so do tell everyone fast. Put it in the group. Magnetism and Matter, EMI, and EM waves. All three together, one shot. Will be taking it. Small notes, one page, and then just completing it. Okay. chances come with Tunansh, okay, that they will reschedule. Okay, but let's see. You put a mail to them, at least they'll reach out to you. चलो let's start then magnetism and matter. ठीक है, किसी और का कोई भी डाउट है आप लोग पुट अप कर सकते हो. Any doubts you have? Now magnetism and matter, you all know the chapter. I won't go much in depth, students. Okay, so anywhere you have difficulty, do tell me. Separate, because we can't go that slow also. So we'll be going a bit fast. Okay. Chalo. If you have any other query, any topic, if you're not able to understand, do tell me. I'll help you in that. Sure. Though chapter is mostly theoretical, this chapter is mostly theoretical. Okay. Ready, everybody? Ready, everybody? Yes, no, yes, no, fast. देर बच्चों स्टार्ट करते हैं. चलो. So this chapter you all have idea, no idea, want to go in depth? थोड़ा सा idea दे दो. Do you all want me to go in depth or just on the surface formula and remove it? Tell me fast. Tell me fast. For this chapter, magnetism and matter. For this chapter, magnetism and matter. You want me to go a bit more detail, like little detail, or just on the surface? Tell me fast, students. For Comet K, if it came, see, again, Comet K, it's tough to say, bro. If it comes, it can come for good, like 2 marks. If not, it can be 0 also. Okay, it can be 1 also. Okay. So I'll just give you the formula, important formula, and for CT also it's 1 to 2 marks. Okay. I've already made you write all the important ones, like, okay. So this is like part of it. So let's see it in a fast manner. Everybody, okay? First, we'll talk about bar magnet. I'll go fast. Do write it with me with fast. See, Comet K, bro, Karthik, there's nothing called important or easy or tough. They can anytime increase the marks. What if they increase it? So if you're learning, do learn it properly. So just like we have charge plus what is it, plus q minus q dipole. So we have the magnetic moment. Bar magnet has plus m and minus m. Okay, and magnetic moment is given by m into 2l. Clear? Now 2l is the distance between these two. Okay, clear? Chalo. Now small but important formula for a revolving electron. For a revolving electron, okay, magnetic moment m is equal to nia. Just I'm giving the important formulas, okay? I'm giving the important formulas. Do write it down fast with me. 25 minutes, the chapter will be done, okay? Next, magnetic field due to magnetic dipole. Just like what is electric field we find out due to the electric dipole, same important formula, magnetic field due to a magnetic dipole. So we'll find at all positions, 1 on the equatorial, 1 on the axial, and 1 at any point on the surface. Clear? Did you get that, Lavanya ma'am? It's like a magnetic dipole. Okay. So just like an electric dipole has two charges, one plus and minus, a magnetic dipole has two poles, magnetic poles, plus pole and minus pole. Just like you refer it as south pole or north pole. Clear? Chalo. Next three formulas are there, students. Do write it very properly. One is axial magnetic field. So that is equal to mu naught by 4 pi 2m by x cube. Similar formula. One is equatorial, mu naught by 4 pi m by r cube, and one is at any point theta, making an angle theta. Three formulas are there. Mu naught by 4 pi m by r cube root under of 1 plus 3 cos square theta. Clear? So if a magnet is kept, it's basically every magnet is a magnetic, what do you say, dipole. So if I want to find what is the magnetic field here on the axis, any point on the axis, I'll use this formula. Any point on this part, I'll use this formula. And at any other angles, I use this formula. Clear everyone? Clear everyone? Clear everyone? Do write it down fast. Do write down fast. It depends, bro. Like if you're taking this distance as r, you can take r. If it is x, you can take x. Okay, up to you. So let's say make it one only. Let's say you have taken this big distance as x from the center. Okay, so that's x. If you have taken from center to this point as R, so it will be R. Clear. This also, if you have taken it as R, it will be R. So whatever is the distance from the center to this point, that is only. Clear? Karthik? Chalo. Next, torque. Just like you put a electric field into that and you get a torque, same thing here. You put a magnetic field, you'll get a torque. So what do you do? This is uniform magnetic field. Always straight line means uniform magnetic field. In that you put up a magnet. Now what happens? This part will experience a force. Okay. This part also experiences a force. So what will happen? It will rotate. So torque is equal to what? M cross B. Clear? Or MB sin theta. That's it. There you have what? If you remember the formula torque in case of dipole. What is the torque in case of dipole? P cross E, P sin theta. Here it is just in place of P, dipole moment over there. Here magnetic moment is there. In place of electric field, here magnetic field is there. Clear everyone? Chalo. Now if you leave a magnet to oscillate, if you tie up a magnet with thread and leave it to oscillate. Now if oscillation is done by a magnet, oscillation of a freely suspended magnet. Oscillation of a freely suspended magnet is equal to T is equal to 2 pi under root I by MB. This formula is important, okay? This formula is important, students. Clear? Clear everyone? Clear everyone? Check it once. Simple. If you have studied the first chapter, electricity, same what you say, electric charges and fields, same thing. Done everyone? Done everyone? A bit to reply fast, kids. हो गया बच्चों लिखे नहीं लिखे जस्ट इंपॉर्टेंट फॉर्मूलाज रिकैप कर रहे in this recapping what you recapped that if we place a magnet, if we place a magnet in magnetic field, what will happen? The magnet will start rotating. The magnet will start rotating. But how much will be that rotatory force? That is given by this formula. That is given by this formula. Clear? Now, and if I leave a magnet suspended freely to rotate, just tie a string and leave it freely like this. So it will, the time period of that magnet is given by this formula. Clear everyone? Chalo. Next is Gauss law in magnetism. Gauss law in magnetism. Chalo bachcho, let's see. Now everybody understand the Gauss law. Very simple, very easy Gauss law. So what is it in Gauss law? See. Now electric part dipole charges can exist alone. You can have a place where you can have plus q charge. But can you have in a magnet like just plus m magnet? Even if you break a magnet, it always breaks in the form of what? Plus and minus. So we don't have a magnetic monopole. Okay. So if you do phi magnetic flux is equal to for the whole surface b dot ds, that always comes down to be zero. Why? Because whenever we put a magnet, it always comes in form of magnetic dipole, because monopoles do not exist. Monopoles do not exist. Clear students, clear students. So net magnetic flux through closed surface is zero. Clear everyone? Clear everyone? Clear everyone? Next, we'll be reading about Earth's magnetism. Some words are there. What are they meaning? That's it. Nothing more than that. Chalo. Written everybody. I'll go a bit fast then. Next is Earth's magnetism. Let me put a picture for this, otherwise it will be difficult to understand. Let's see. First, we'll listen to a word called declination. Anybody heard of this word? Next is about dip or inclination. This is nothing but the angle between magnetic meridian and geographic meridian. And geographic meridian. Now this is angle between, don't worry, you'll understand. Total magnetic field, be it to its horizontal component. So let's see you have your magnet, what do you say, Earth's magnetic material, uh, Earth's magnetic field is like this, B, okay, making an angle theta with the horizontal. So if you want to break this, so what will happen? It will be cos theta here, Earth's magnetic field, it will be cos theta component here and sin theta component here. And we know the magnetic field of the Earth is equal to root under of BH horizontal component plus vertical component. Clear? Clear? Now, what is geographic meridian and what is magnetic meridian? Anybody has any idea? Geographic meridian, magnetic meridian? See, students, what is magnetic meridian is? It's a line passing through the magnetic axis of the Earth. And geographic, it's a line passing through the geographical axis south-north. Okay, so we know Earth south-north and Earth's magnetic south-north is different. Let's say I'm drawing an Earth. It's a bit, what do you say, flatter. Don't worry. Clear? So if I make a dabba here, let's say a magnetic part. Now this is geographical axis. This is what? Straight geographical north-south. This is our geographical axis. Okay. Now magnetic meridian is nothing but magnet. If I put a magnet here, student, if I put a magnet here, it will be just slight tilted. Clear? So the magnetic axis is just slight tilted like this. Clear? And that is called magnetic meridian. Now what I said is this declination is the angle between magnetic meridian and geographic meridian. So this is the angle. Clear everyone now? Clear everyone? Come on, say yes, no, kids. I made a diagram also, though it is not that good, but still yes, no deserves it. Correct? Now let's draw that part. Okay, one drawing, that's it. So this is your delta. This is your theta. This is magnetic meridian. This is geographic meridian. Okay. This is BH, Earth's horizontal components of Earth's magnetic field. It is angle of dip and this is angle of declination. Clear everyone? And this is the magnetic field, okay, Earth's magnetic field. So what is it showing? See, this is my geographic meridian. This is my magnetic meridian. In between the angle, this angle is nothing but angle of dip. And from this is the horizontal part. Okay, this is the Earth's vertical, and this one is the magnetic field Earth. Clear everyone? I'm not able to show with a 3D diagram. Later I'll do. Okay, when we have more time. For here, for today, this much is okay. Okay. Chalo, let's see next. Next is what are the you all have written now. Chalo. Now let's see. Now a lot of times they'll ask you some concept, though it is boring, but still, where is the dip minimum and maximum? So dip is a minimum at equator, and at poles it is maximum. So at least you should know these values, okay? Now if you can see, a dip is done. Now after that what we have is, now we'll talk about some magnetic materials. Now you all know about magnetic materials and some important terms. This all keeps coming. What is permeability? Uh, then what is the susceptibility, coercivity? Okay, so let's talk about those magnetic materials. Talk about the terms. Number one, permeability. What is permeability, students? Anybody? These formulas are also very important. These formulas are also very important. These formulas are also very important. Now tell me, what do you mean by magnetic? Anybody? What do you mean by magnetic permeability? See, permeability is nothing but, if you say one point, ratio of magnetic induction to magnetic intensity. Though we haven't done, we'll come to that. Ratio of one term, magnetic induction to magnetic intensity. What is it? A ratio. Now I'll say, sir, what about layman terms, some simple terms? Basically, it measures the conduction of how many, what is the magnetic field lines can pass through the substance. So how easily a magnetic field line can pass through it. So if some material allows a lot of magnetic field lines to pass through it, so what I'll say, its magnetic permeability is more. What is the formula? Mu is equal to B by H. Mu is equal to B by H. We'll come to the definitions of B and H also in details. Don't worry. So mu is equal to B by H. Clear? Clear? Next is magnetic intensity. Magnetic intensity. Each term is very important. Understand it, you'll be done. Magnetic intensity. Now, what about magnetic intensity, students? So it's basically the capability of the magnetic field to magnetize the substance. What is it? Basically, capability of magnetic field to magnetize the substance. Clear? Now, what is the formula? H is equal to B by mu. Just now we wrote, if mu is equal to B by H, H is equal to what? B by mu. What does it mean? Magnetic intensity, the capability of the field to magnetize a material. That's it. Very simple. Clear? Next we have intensity of magnetization. Its unit is H. Written everybody, written everybody. Can we go to the next page? Written everybody, can we go to the next page? Next is intensity of magnetization. Next is intensity of magnetization. Now, what is intensity of magnetization, students? Degree to which a substance is magnetized. What is it? Degree to which a substance is magnetized. Clear, everyone? Now, a lot of times we write this formula also. Net magnetic moment developed per unit volume. Net magnetic moment developed per unit volume. I is equal to what? M by V. M by V. Clear till here? Clear till here? What is intensity of magnetization? Very simple. I is nothing but degree to which a substance is magnetized. Degree to which a substance is magnetized. Clear? Next. Next we wrote which one? Permeability, magnetic intensity, intensity of magnetization. Magnetic induction. Magnetic induction. Let's see magnetic induction. So basically, what is magnetic induction? Number of magnetic lines, of induction crossing per unit area normally. Per unit area normally. Clear? Through the magnetic surface. Through the magnetic surface. Do write it down in one go so that your formula and everything is done. So here, what is the formula? So total magnetic lines of induction crossing per unit area normally. So B is equal to B naught plus mu naught I. So B naught, we already know what is it. B naught formula. If I take this one as B naught, if I can take this one as B naught also. B naught means initial 8 p.m. 8 p.m. So what I can write, that is equal to mu naught, or B also mu naught H B dash I can write mu H plus mu I. Okay, 1 second. 1 second, student. Let's see what we can do is, see the total magnetic induction B, that is the magnetic field, what is it, due to magnetic field and plus induced one, both. Okay, that is equal to mu into H plus I. Mu into H plus I. This also is important formula. Clear, everyone? Clear, everyone? So basically, students, let's recap it so that if you are not, you are able to understand. See, this part, it just tells us how easily you can be, magnetic field can pass. This tells us the capability of a magnetic field lines to magnetize something else. Okay. Next, it tells us the degree to which a substance, let's say the substance is this, to what degree, like 60% it can be magnetized, 70% can be magnetized, to what degree it can be magnetized. And this is the net total, which is due to H and I both. H means due to magnetic material, what is it, due to magnetic intensity, how much you are getting, and due to intensity of magnetization. Both, if I combine it and find out the magnetic field, I'll get this. Clear? Chalo. Written, students. One last, magnetic susceptibility. Almost very, what is it, similar terms. Okay. So if you see magnetic susceptibility, that is chi. Okay. We talk it as susceptibility. It's basically how easily it can be magnified, how easily it gets magnetized. So this is equal to I by H, I by H. So these all formulas are very, very important. Okay. Clear? Clear this part, student? Now let's read a bit more about para, dia and ferro, so that what is it, you all are able to put it up in that para, dia and ferro, and this gets done. Okay. After this, in case we want, we can put up a bit of maths because you all are done with physics, or some questions we will take. Okay. Chalo. Here we'll take diamagnetic, para, and ferro. So here, first in terms of permeability, mu is less than 1, mu is greater than 1, mu is much, much greater than, like, greater than 1. Okay. Susceptibility chi, it is small and negative. Here chi is small but positive. Here chi is large and positive. Clear? Example like copper, silver, zinc. Here aluminium, Mn. Okay. Here iron, nickel. Clear? Now if I put it in a magnetic field, it will be weakly repelled. Weakly attracted. Weakly repelled. Clear? Shall I write down this one fast, students? What is it? Dia permeability should be low, less than 1. Para should be great, more than 1. And ferro should be very huge. Now, susceptibility should be small and negative. Here small but positive. Here large and big. Examples you already know. If you put in a magnetic field, how does it behave? You already know. Just write it down fast. We'll go for the next. Are you all getting it? Not getting it? Do tell me fast, students. Is it getting difficult, a bit boring? Because chapter is bit boring, nothing much to like, what to say, it's more of theoretical. Okay, so if you want, I can directly go to the questions. Chalo. If you have done once, I can go to the questions. Okay, next we have Curie's law. Okay, now what did Curie say? And Curie's law, let's read about it. If you want, one diagram is important. Okay, here one diagram is important. I'll just put one diagram. See, if I have a diamagnetism material, so it's basically a tendency to move from stronger to weaker part of the electric field. So you'll see a lot of times a question comes like this. It is for diamagnetism. Okay, field lines is repelled and field lines is inside is reduced. Okay, para, you'll see a lot of field lines inside. Clear? Oh yes, 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 correct, 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 correct. Ferro is strongly attracted. Ferro is strongly attracted. Now, one thing, tell me, if something is strongly attracted, so does that mean it is weakly repelled? Because see, ferromagnetic substances they move from the region from of weak to the strong magnetic field, and they get strongly attracted to the magnet. So this one will be what? Strongly attracted. Correct, Lloyd sir? I just didn't saw. So one will be weakly repelled, weakly attracted, and this if I put in the magnetic field, it will be strongly attracted. Now next is Curie's law. Now what does Curie's law say? One second, students. In the ferro part also we haven't written the diagram, no? Here also in ferro, the particles prefer to pass through it more closely, okay? Clear? Chalo. Now next is Curie's law. Almost we are done. So Curie's law tells us that magnetization of paramagnetic substances is inversely proportional to absolute temperature. What do you mean by this? That magnetization, if you want to magnetize a paramagnetic substance, that is inversely proportional to absolute temperature. More the absolute temperature, less it will be magnetized. Now next we have a formula, if you remember, xm is equal to c mu naught by t. Now what is xm? You all know. What is xm? We just did. We did about mu also. What is mu? And what does this formula tells us? Anybody? In Curie's law, what is the formula telling us? That if you want to magnetize a paramagnetic material, that depends entirely, that is inversely proportional to what? Absolute temperature. Clear everyone? Clear everyone? And xm is equal to, susceptibility is equal to c times of mu naught by t. That is Curie's law. This is Curie constant. Clear? Now next is Curie West Law. Next is Curie's West Law. Now what does Curie's West Law says? So it describes the magnetic susceptibility of a ferromagnetic in paramagnetic region. It describes the magnetic susceptibility of a ferromagnetic in a paramagnetic region above the Curie point. Above the Curie point. Clear, students? So what is telling that at very high temperature, ferromagnet can become paramagnet. Okay. And what is the temperature range? How do you find the formula? The temperature is nothing but the Curie temperature. So the transition of, or the transition temperature from ferro to para is called Curie temperature, Tc. Now see, everybody understand and do reply if you're not able to understand also. Okay. See, Curie West Law, he said, sir, he said that if I'm taking a ferromagnetic substance, putting in a paramagnetic region, how will it behave? And how will its value of this susceptibility value will change? Okay. Now, it says susceptibility means what? Just now we read susceptibility means what? How easily that ferro can be magnetized. Okay. Clear? So he said that The transition will happen from ferro to para at a temperature called as Curie temperature, and that is Tc. And then he gave the value. Clear everyone? Clear everyone? Clear everyone? Clear everyone? Did you got it, Karthik, or it went above head? Yeah, a lot of theory just doing gives us what you say. It becomes too boring. We need few examples also. At least questions we need. Understood, huh? Okay, chalo. Next is hysteresis curve. Everybody knows about hysteresis. Next is hysteresis curve. Now, hysteresis curve is something like this. So, what happens? Now, the graph is between B and H. What is B? Magnetic induction B. With magnetic intensity of a ferromagnetic material. Magnetic intensity, okay. So, what happens is, if you see here, in the hysteresis part, what happens is, now, what is the meaning of word hysteresis? It means lag, to lag, okay, or lagging behind, or lagging behind. So, if you see, something is lagging behind. So, the intensity of magnetization, okay, is lagging behind H, okay, and then this whole cycle is there. So, in this whole cycle, what we do, we first magnetize the substance, then again demagnetize it, again magnetize it, and again demagnetize it, okay. And then we get the different factors about retentivity, coercivity, and all that, okay. So first we are magnetizing it, going above, then it is coming to point A, from demagnetizing going to point D, again we are magnetizing from E, again going back to point A. Clear? So let's see. Now here, this value is known as coercivity. This value in this hysteresis curve is known as coercivity. Now why it is known as coercivity? Anybody? Come on, this is all you have studied now in 12th. A bit idea? See, we are just doing three things. First magnetizing, then second step demagnetizing, again magnetizing. That's it, nothing more than that. Okay. Now, In this curve, the first part, if I write OA shows us the what? Which part shows retentivity? Which part nobody is telling any answer? Okay, let me explain the experiment. See what we are doing. We have taken an unmagnetized material, put it inside a solenoid. Put it inside a solenoid. So a non-magnetized material is there inside the solenoid. Okay. Now what we have done, we are increasing the current. So the moment current increases, what will happen? Magnetic field will be there. Now this magnetic field will influence this also and make it an electromagnet. Okay. After the saturation point, we cannot increase current further. So after that, the current decreases. Okay. So that time is known as the max value of magnetization that can happen. और खत्म है सर, इसमें कुछ नहीं है. ठीक है, ये हिस्टेरिसिस है एंड देन डन. इसको तब ये नेक्स्ट वाले चैप्टर के साथ थोड़ा सा पहले करके कर देते हैं. ठीक है, एक 10 मिनट का ब्रेक ले लो. 10 मिनट के ब्रेक के बाद विल डू अनदर चैप्टर एंड विल जस्ट रिकैप फ्रॉम द बैक सेक्शन. ठीक है, थोड़ा सा ये चैप्टर्स के लिए थोड़ा सा हार्डवर्क करना है. हिस्टेरिसिस नहीं है ना. देखो हिस्टेरिसिस में क्या किया हमने, एक क्या बोलते हैं, अनमैग्नेटाइज मटेरियल आयरन को रख लिया, पुट इनसाइड अ सोलेनॉइड. ठीक है, पुट इनसाइड अ coil like this and wire coil windings like this. So we know whenever we pass current, it will be electromagnet, it will be magnetized. So till the current is magnetized, getting to the maximum volume, it will be magnetized. The moment we switch off the current, it will retain some of its magnetivity, it will retain few of its magnetivity, but after that it will go. Now we are switching back the current in the backward direction. So what will happen? It will again be magnetized but in the opposite direction. Again you switch it off, it will again come back, again you do it. So like that you keep on doing it. Okay, clear? थोड़ा सा ये बोरिंग चैप्टर है, इसमें ज्यादा कुछ इसका नहीं था. ठीक है, put it for like take a break for 10 minutes. After that we'll start with EMI. After EMI again we'll come back to the last part, hysteresis. Hysteresis part I'll just put up a small, what do you say, picture and I'll explain you, don't worry. The topics which you are getting difficulty, what do you say, fresh in the morning also, we'll keep it like only those topics which we are having a bit difficulty to understand, we'll again go through with the diagrams and everything. We'll go through. Okay, chalo, we'll take a 10-minute break, we'll be back. Okay. Mango chip. ये लोग पुराने से बर्फ खा रहे हैं. Hello everyone, come fast, come fast. I'll be explaining the hysteresis part. Let's see, let's get it done. Let's see everybody. See, Ravindra, since admit card is out, so chances of getting it postponed is very little, bro. Okay. So exam chances is very little to be postponed. Now, Karthike, let's see, let's finish the hysteresis, okay? And then we'll be going for maths at 8, okay? Again, night will take care in the PYQ, okay? This one. Let's see. So what happens in hysteresis is, I'm again explaining in details. Everybody see. Just put a message in the group. Sir is explaining hysteresis part. +70 in all of it. To score 70 is not very tough task. In CET, I already, sir, I have given you, I've already given you the important topics. Study them, you'll get score more than 70 I have given the list of important topics. From there, you can easily score 35 to 40. Three to 4 days. Yeah, you can do that in 3 to 4 days also. All important topics I've given. See, physics. Yeah, it's a video. I'll send you the link. Ping me in this number, you'll get it, okay? Chalo, everybody, let's see. Karthik, you there? You there, Karthik, bro? Give me a call, Mohit. I'll help you out. I'll guide you in that, okay? Don't worry. Yes, let's see. So, be ready. Let's destroy what do you call it as? The hysteresis loop. Okay. So first what happened is, imagine that your friend, who's your friend? Lucky. Okay. Lucky went to the factory, and what he did, he saw a big solenoid, okay, like this. It was connected to a some switch. Correct, Lucky? So switch was here, he switched it on. And what he did first, he inserted a any material. He inserted a ferromagnetic material. Clear? So he inserted a ferromagnetic material and he switched on the current. So the moment he switched on the current, what happened? From a bit, what do you say, the current started flowing, it started getting magnetized. This whole solenoid behaved like a magnet, and slowly it started getting magnetized. Okay, till it went till A part. He was very happy. He told, yeah, Karthik, I switched on the machine and the material got magnetized till A point. Karthik said, okay, very good. He said, let's now again increase more current. He said, how will you get more current? He said, let's borrow from the nearby pole station. So he put up one wire and he brought some extra current to his factory, and now again he increased. But this time what happened, even after increasing the current after this point, it remained, the magnetic property remained till A. The magnetization remained till A only. He said, why, bro? So Karthik now explaining that, see, whatever the domains were there, the lines, what you say, unpaired electrons were there, they already got paired up by the initial current. That current, whatever the magnetic field it produced, they got paired up. Now, even if we increase, they're already paired. We can't produce extra, no. Just like, see, in photoelectric effect, we cannot bring more than a certain electrons. Why? Because that metal has that many of electrons. So same thing in every material, there are domains like this, which are like unorganized, like this, like this, like this. So once you put up a magnetic field, so they get organized, oriented. After they're oriented, even if you put more current, they won't do anything. No. So done, clear. So he said, no, bro, not more than that it can. So now what he said, okay, Karthik, bro, whatever the current and all we have taken from others, let's, what is he, send them back. Now he started reducing the current. He reduces. He came back to zero. He said, bro, I reduced the current and I came back to the 0 point. Now I'm not supplying any current. Is it correct? But still see, it has this much of magnetism left, though I'm not providing any current. So that is called retentivity. That once it became magnet, it is able to retain this much of magnetism, even though there is no current, to support it. Clear? After that, he said, bro, why not change the polarity and then supply the current? So now it made the current in opposite direction. Now what happened? So now they started cancelling the old retentivity, and a point came where it became full zero. By passing the negative current or the current in opposite direction, they were able to remove this magnetism and bring it to zero. They increased, and then they came to the maximum point here. That is D. Clear? Now again he said, let's now increase in the current in the positive manner. Again he increased in the positive manner. So after he came to zero current, he started decreasing, came to zero. Here also this was the retentivity part. In the negative part, it retained a bit of magnetism. Now he started again increasing in the positive part. Positive. Again, this graph keeps repeating. Clear, Karthik? Clear, Karthik? So this is the whole story behind hysteresis loop. Okay. Got it? Didn't get, bro? Clear, everyone? Now, good. So this chapter is done. 15 minutes later, we'll end the class right now. 15 minutes later, we'll be starting the maths part. Okay, 8 to 10:30, we'll be doing the maths. A revision part will be very fast revision. Mohit, do join it also. Limits, continuity, differentiability, and AOD. All questions, just PYQ. So be ready, everyone. Okay, chalo.